which is negative 125 raised to 1/3. So, what radical is this? The cube root. It's the radical with the cube root, right? In other words, the index 3. Yes, negative 125. So now one option will be to remember what this represents. You may or may not know what it is, so let's take it to the side. 125 is divisible by 5. But then when I divide, so let me show it. Maybe it's better with a calculator so you can see it. So 125, anything that ends in 5 or 0 is divisible by 5. And then 25 is 5 times 5. So then I already know that this is 5 times 5, in other words, 5 to the 3rd. Of course, with negative, because it's negative, right? So we have negative 5 to the 3rd power. And remember what this is. The power over the index. When you divide the power over the index, what do you get? When you divide 3 by 3, you get?
1.
Yes. So then the answer is simply negative 5. Can you do this with a calculator to check? Yes, you can. So just remember, put parentheses because it's a negative number, negative 125, close, caret, which means the power, and that is 1/3. Oops, I didn't mean that. 1/3. So when I hit enter, I have to get negative 5. If I don't get negative 5, something is wrong. But again, the calculator will give us nice answers only if 125 is a perfect cube, and it is. So careful with that. Okay, let's take a look. How would I rewrite xy to power 1 over 11 as a radical? Can anyone help with this? Once you understand the formula, these are simple problems. Can anyone tell us how to write? Which radical is this? In other words, maybe I should ask, which index? What is the index of the radical, please?
11.
Yes. And the power is 1. That's all you have to write. Very simple. Once you understand it, of course, and you get used to it. Okay? This is the same thing with negative 125. So if you want, you can simply put it in parentheses, negative 27, close, caret, which is the power, parentheses, 2 divided by 3. If it's an integer, it's okay. If it's not an integer, then you have to do more work. Okay, how do I write this one? xy, everything to power 5 over 7. What is the index of this radical? Let's establish or find the index first.
7.
Yes, and all you have to do is just copy xy to the 5th, or you can copy it x to the 5th times y to the 5th, and that's it. Both are perfect. Okay, more practice with radicals. Rewrite the expression with rational exponents. Okay, now they're asking us to do the reverse. So we want to write the square root of 10 as 10 to a fraction. Which fraction?
Would it be 1 over 2?
Exactly. 1 over 2 that is not written. That's the only one by convention we don't write. The square root. Excellent. Great job. Thank you so much. Okay, for this one, what will you say? The cube root of 20. How do I write the cube root of 20? With the exponential notation. Oh, 20 to a power.
1 over 3.
That's it. So please remember, this is easy to remember, just these two. The square root is something with power 1/2. The cube root is whatever but power 1/3. Okay, so let's see 13, the same thing, but it's a product. So let's work on this one. So the cube root of 15x. You can write it like this, or you can write it like this. Power, power, power. It's going to be the same power. And we already know what the cube root is. What power is the cube root?
1/3.
Excellent. Thank you very much. That's it. Nothing. They look complicated, but once you understand, you cannot ununderstand it. It's too easy. So let's also write this one, the square of x to the 21st power. Once you see it, you cannot go back. So this is x to a fraction. Why is it a fraction? Because it's a radical. So the power is a fraction when we are looking at a radical. So what do I have?
21/2.
That's it. It's easy. Once you understand it, it's just a symbol. It's nothing else to it. Okay? Let's see and move on. Okay, how would you write this one? The 4th root of x to the 5th. It's x, and just tell me the power.
Five over 4.
That's it, 5/4. 5 is the power, 4 is the denominator because the 4 is the index. Perfect. Thank you. Yeah, they're throwing at us now a product of 3. Let's do that too. So this is the 4th root of 12xy and everything to power 3. So what I will do with this, I will write 12 to 3/4. X to 3/4 and y to 3/4. This is a power, which gets inside as well, and 4 is the index. Exactly the same with a product of 2 factors. Everything is the same. Let's see. We write the expression with rational exponents, the same thing. We write the following expression with a positive rational exponent. Yes, I like this one. So 361 to power negative 1/2. We need to review this. These are important. Okay. So whenever we take a power to a negative exponent, so this was not done last week. Okay, okay. So when we raise a number to a negative exponent, what symbol is this? What does it represent? What does it mean? Any negative exponent represents a what? Any negative exponent represents a
Infinite notation.
It's a fraction.
Oh, sorry.
Right? So a to negative n is 1 over a to the nth power. Any negative exponent, please remember, any negative exponent is a fraction. 1 over the same thing, but with a positive exponent. Good. What do I do next? What radical is power 1/2? Meaning the square root. Okay. Okay, so now you put it in the calculator and you just take the square root and you'll see it's a perfect square, 361, 19. So the answer is 1 divided by 19. And that's it. Next, number 19. Same thing. Let's work on this one or this one because they have negative exponents. Let's practice one more with negative exponents. And I want to talk about this. I'll talk about this right now, actually. This is very important. So, number one, when we have the square root or any root, the nth root, any root, from a times b, this is the same. We wrote this before. This is not the first time. So the nth root of a times b is the same thing with the nth root of a times nth root of b. In other words, the square root of ab equals the square root of a times the square root of b. If you remember, we wrote this as well. If it's a fraction, yes, also I can write it like this. If it's a square root of a fraction, I have the square root of the numerator over the square root of the denominator. But we also wrote this. Any index of a sum or difference never changes into anything, plus or minus. So you can remember it very easily. So anything with a negative exponent is a fraction. Please remember that. Anything that a radical is on top of a product, it can be written as the product of radicals. So the radical of a product is the product of radicals. The radical of a ratio is the ratio of radicals. But the radical of a sum cannot be simplified. The radical of a difference cannot be simplified unless you combine these. Yes. So if I tell you find the square root of 9 plus 36, you can say the square root of 45. But you cannot say the square root of 9 plus 36, that is the square root of 9 plus the square root of 36, because it's not true. This is 3 and this is 6. 3 plus 6 is not the square root of 45. So this is incorrect. This is correct, because you combined or you added these two numbers and you got that. That's perfect. But you cannot separate it like we separate products and we separate ratios. You can never separate this. It's not possible. You can combine and get the answer. So right here, this is tricky, right? They say, is a plus b, which is the nth root of a plus b, the same thing with the nth root of a? No, absolutely not. This is absolutely false. The statement is false. The true statement is, I don't know what they want. Type an exact answer using radicals as needed. Okay, so they want us to write a plus b. That's it. So there is nothing else. You can. So what did I do? Oh, I didn't put the index in. How do I put the index? I forgot to put the index, sorry. Sorry about that. That's what I did. Yeah. Okay, so that's the only thing you can do. You cannot separate because it's a sum of two quantities that we don't have. Okay, so let's look at another a fraction with a negative exponent. And the fraction is 8 divided by 27, everything to negative 1/3. Good. So any base raised to a negative exponent, don't look at the base just now, any base raised to a negative exponent represents a, we said it a few minutes ago, it represents a
fraction.
Exactly, thank you so much. Please remember that. It's 1 over this to 1/3. Now, which radical, because it's an exponent that is a fraction, it must be a radical. Which index will this radical have?
Cubed.
Oh, you said cubed. Okay, yes. Sorry. Perfect. So now, remember what we just wrote. the cube root of a fraction can be separated. Okay, so I will write the cube root of 8 over the cube root of 27. Can anyone tell us the cube root of 8?
2.
Excellent. Can anyone tell us the cube root of 27?
3.
Excellent. I just have to flip. Why do I flip? Because I'm dividing a fraction 1 over 1 by 2 over 3. So the rule of dividing fractions, I copy the top, but I don't have anything to copy. It's 1 times 3 over 2. And this is it. Yes, you could, just in case, if you have any doubts, you can put in the calculator, and we have to get 3 over 2, which is 1.5, and we can change it to a fraction if we want to. So you will have parentheses, but you still have to show your work. I'm just showing you how to verify your work. Power, in parentheses, don't forget, -1 divided by 3. And when I hit enter, I have to get 3 over 2, but it will show up as 1.5. Okay, you can change it into a fraction using math, fraction, and now it's 3/2. Okay, do we need other examples, or are we okay with everything here? You will let me know when we review next time. Okay. Next, I would like to talk about solving linear inequalities and solving absolute value inequalities. These are the last 2 sections I didn't tell you. I skipped one section that requires a little bit more time, so I wanted to finish everything else for you, and I'll explain which one I skipped, and hopefully we'll start it today. Okay, so linear inequalities. Okay. Easy, refresher, it doesn't matter. We're going to work on as many problems as we can. Okay, so the notation 2 less than 5 means that 2 is to the left of 5. 2 is less than 5. 2 is on the left of 5. Okay. Yes, thank you. Now I want to talk about interval notation. So this is an interval notation, left parenthesis -2 comma 8 with a bracket. I need to explain this. So what does this mean? A parenthesis and then a bracket. On the number line, 0 is in the middle, negative infinity and infinity. -2 is somewhere here. I'm not going to use units. I'm interested in the explanation, not in exact. So -2 is here somewhere, and -2 has a parenthesis, so it's an open point. It's not a full point. 8 has a bracket, so 8 is somewhere here, but it's a full point because of the bracket. So if you want to present this, you will, on the real line, on the number line, you will show it like this. In other words, how will I get an answer? Something like this it will be looking like from -2 to 8. X is a number greater than -2, greater than -2, but less than 8, less than or equal to 8. So this is what we call interval notation. Interval notation. Okay. What about this one? -6 to infinity. So -6 to infinity, infinities are always parentheses because they are symbols, they're not numbers. When we see a parenthesis, it means that that point is not included. -2 is not included. because it's a parenthesis. 8 is included because it's a bracket. How do I represent this? This is also an interval notation. Okay, on the real line, 0 is in the middle, negative infinity and infinity. Negative 6 is an open point because negative 6 is not in the interval. And it's everything between negative 6 and infinity. How will this look like in an inequality? It will look like this. Greater than negative 6 to the right of negative 6. Okay? Select the answer that, okay. The negative multiplication, yes. So, page 10. So I hope you agree that 2 is a number less than 5. What if, for whatever reason, I want to multiply both sides by negative 1? Multiply or divide? We're going to look at examples in a minute and you'll understand when that is necessary. Okay, so now if I multiply this by negative 2 and I multiply this by negative 5, look what happens. 0, 2, and 5. But negative 2 and negative 5. So this is less than 5, but now this is less. In other words, every time in an inequality, I multiply or divide by any negative number, not necessarily negative 1, any negative number. If I multiply or divide, I must switch the inequality symbol. If it's less than, I have to change it into greater than. If it's less than or equal to, I have to change it into greater than or equal to. So every time we multiply, I'm going to write this note here, note, switch the inequality symbol when multiplying by a negative number or dividing by a negative number. Always. So you will see when this is necessary. So the negative multiplication property of inequality states that if A is less than 0 and C is negative, then AC becomes greater than BC. Okay? I don't want to scream at it. It screams at me again. Okay. Okay, I just want to get to examples. Okay, perfect. This is our first example. This is the first inequality that we are going to solve. So 4x minus 1 greater than or equal to 23. And we will present the answer in interval notation and also we'll graph it on the number line. So if this were equal, what would you have done? If this is an equation and this is the equal symbol, what would you have done first?
Add 1 to both sides.
Oh, of course, that's exactly what I'm going to do. Excellent. If this were the equation or the equal symbol, what would you have done next?
Divide by 4.
That's it. Done. This is it. So this is our first inequality. Let's present it on the number line. 6 is somewhere here, but it's a full point because of the equal symbol. Bracket to the right. And that's exactly what I have to write as the interval notation. Bracket 6, comma, infinity. This is it. There is nothing else to it. Now, if you want, what is added here versus equations is the interval notation. We didn't have this for equations. So in other words, if you choose any number from 6 to the right, the inequality is true. If you choose a number from negative infinity to 6 without 6, that will not be true. Because if I choose negative 1 is not greater than or equal to 6. But if I choose 10, 10 is greater than or equal to 6. That's all there is to it. There's nothing else. Here's another one. Ready? And that was 11. Good. So we have 12x minus 13 less than or equal to 3x minus 15. First step. Exactly like it's an equation. Only the final step is different.